have discovered a few things the hard way. First of all, my original plan was to run, when you turn these switches on, it'll also turn on these indicator lamps to let you know when heating element bank 1 and heating element bank 2 were under power. Didn't work. I tried a handful of different things. I tried running them off of, because those are LEDs, I tried running them off of the SSRs, because the SSRs take a DC input, but that DC input makes a fraction of an amp at 6 volts, not enough to power an LED and not enough to trip an automotive 12 volt relay, which I also tried. And then I said, well, I got a 12 volt automotive relay, why not try getting a 6 volt? So I got a 6 volt automotive relay. Also not enough amperage to trip that. So what I've decided to do, I'm going to skip the relays. I'm going to skip running off the SSR and the DC side, and I am going to install double pole single throw switches that have 2 separate circuits on them. So when you turn the switch, both of these circuits will run current through them. So the idea is, on one side of the circuit is going to be the turning on of the heating element. The other side of the circuit is going to run the LED light. Now these LEDs are actually 120 AC. I'm assuming there's some kind of rectifier or some kind of voltage changeover in here that goes from AC to DC. So what I'll do is I will run LED indicator lamp on this side and heating element turn on that side. We have one for each bank. Let's get these switches installed. Let's get the alarm wired up and see if we can't get this thing functioning a little more properly. And I know if you're looking at this, you're thinking, well, it's got 4 contacts, why don't you just use these? The problem is this switch is a double pole, double throw. So you have 2 separate circuits in here, but one side is normally open and the other side is normally closed. That means one side is always on, one side is always off until you flip the switch and then they reverse. I don't need that. I need 2 switches that are both going to throw the same open to closed or closed to open. I don't need throwing one way and the other way. So that's why we're going with the double pole single throw. All right, we're good. And we're going to install the other switch as well while we're here, because it's going to get more difficult as time goes on. And this is going to be the output that's going to SSR2. There we go. You'll feel it slot in there when it finally sits right. So the next thing we have to do is run the other side to our indicator lamps up here. Now our indicator lamps are already running. I already have a neutral going to all the indicator lamp. So all I have to do is run a hot line, a 120 hot in, and then a 120 hot out to the other side of the light. So what I'm going to do is I'm going to take the 120 hot that's going to the light here. That is going to be, I'm going to move that down to my input, and then I'll clip it off the relay, and we'll plug it into one of my 120s. This whole bank here is 120 hot, so I'll just plug it into one of these. I've got 2 open ones at the top, so that will work. Well, that's a good sign. The indicator lamps are not turned on. So what we're going to do, we are going to turn the panel on. This is the master power for the panel, and this is something I'll do too. I've got one of those cool little label printers, the little brother label printers, and they've got black on clear, and I'll print labels for all these. So this is the master power. This is heating element bank 1, heating element bank 2, fan, and lights. So master power. The voltage and amperage is always on, as long as the unit's plugged in, because I've got it running right off the main, and I'm fine with that. It's virtually no draw on this. It's just a little LCD display. So on we go. This is good. That light is off. Let's try it. Hey, how about that? And it is powering the heating element. You notice how this went to 17 amps. Turn it off, goes back to practically 0. And element 2, 33.9. Spot on. Couldn't be happier. That's exactly what we were looking for. I can feel the heat. They're not red yet, but I can feel the heat. It's not a question mark for me. I already know they work because I've been using them. I see the glow. There's the fan up here. We'll turn the lights on. Get you a little closer to the fan so you can see that. You see the turbine blade there? It's not very loud. And it doesn't move a ton of air, but it moves enough. And what that fan does, it sucks the air up through that intake, right in front of the light here, and right in front of the light there, goes down each wall, inside the wall, and comes out down there in the vents that say danger, paint melting gas. Air is technically a gas. And it comes down this wall and comes out that one on the other side. So we are in good shape here. There we go. That thing's kind of a bear to close, but it's perfect. You want it to be difficult. That means it's compressing the seal, the tadpole gasket. All right, very, 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 very happy with this. One major problem solved. Now the next thing we have to do is hook up the alarm buzzer. Oops. We have to hook up the alarm buzzer to the timer. Now, the PID, I got two because my original thought was to put one on the over temp warning for the temperature controller. But like I said, it's never been an issue. It may be an issue when I fix the wiring for the thermocoupler, but in its current state, not an issue. So what we're going to do is we're going to wire up the timer, the warning buzzer, and call it a day. I did take the time to program this, and you hit this little reset button. Now I programmed it for 10 minutes. That's the SV is the set value. There we go. Now when it finally hits 10 minutes, this A will switch to B and it'll output voltage on the B side. Let's open this bad boy up and I'll show you. It outputs voltage on the B. That guy right there. See, it's normally open. Now it looks like it doesn't output voltage. This might be actually an output on 4. So what we're going to do, just to make sure we got just to make sure everything's right, what I'm going to do is I'm going to let this timer hit 10 minutes, and then I'm going to come in here and I'm going to see exactly which one of these circuits is outputting voltage that I can use, and we'll go from there. Okay, so we've hit our 10 minutes. We switched to B here. Let's open this bad boy up and see exactly where we're getting voltage and what that voltage is. If we're lucky, there'll be a 120 output somewhere, but I don't suspect that we're that lucky. I'm going to try 7 and 8 first because 7 common, 8 normally open. Nada. Let's try the B circuit. Okay, nothing on AC. Okay, yeah, we've got no 120 output. Okay, so we're going to switch this over to DC. It looks like all our outputs are going to be DC. All right. So we got a 12 volt output down here on 4 and 5. And on 11 and 12, let's see what we got. See if we have anything here. Yeah, nothing. Okay. So 4 and 5 are going to be our DC output. I'm going to do a continuity test. And I'm going to do this continuity test on 6 and 7. 6 and 7 are normally, or pardon me, 7 and 8. If 7 and 8 are, if we have continuity on 7 and 8 right now, what we're going to wind up doing is just running a circuit there. We'll bring voltage to it. Okay, well, we can do the same here. So what we're going to do is we're going to run 110 volts, because I do believe these are 110. We are going to run a 110 line from the panel to this top center screw here. That will be your B common. And then we're going to run an output from here to the buzzer. Yeah. That's what we'll do. The good news is, now we know we don't need these pigtails, because they are not going to work on the kind of amperage being supplied by this guy. It's very unusual to see 120 volt LEDs, because LEDs are diodes. And diodes only allow current to flow one way. But if you look inside of here, you'll see there's actually a circuit board. And I'm guessing that circuit board has a rectifier on it to limit the flow of electricity to one direction. Now we should be good. So what we're going to do is plug her back in, turn it on, set the alarm, and pray. Well, that's exactly what we're going for. And while it's not particularly loud, it is loud enough to hear it. So this is terrific. And it has, you know, the red illumination. It's not super bright, but again, you'll notice it. This is exactly what I was hoping for. So now we have a fully functional cabinet. Everything is exactly the way I wanted it. Awesome. So we have our hot coming in to the bottom of the master power switch, going out of the master power switch to the master power indicator lamp. From the master power indicator lamp, it goes up to the PID. From the PID, it goes over to the timer. With the exception of turning the switch on and off, indicator lamp, PID, timer are all, for the sake of schematics, they're all in parallel. Basically, they're all running off the same wire. Now the common is actually a home run all the way back to our neutral blocks up here. Now the common runs into the light here, and then it also daisy chains to all the other lights. You think of the common, it's similar to what a ground would be in a DC circuit. It would be similar to the negative terminal. This is AC, so it's not really a negative terminal, but it allows the circuit to be completed. Now that we've got the common in here, when we turn this switch on, the PID will turn on, timer will turn on, and the master power indicator lamp will turn on. So on the PID, your power inputs and outputs are terminals 1 and terminals 2. Your SSR turning on and turning off, your control outputs for SSR, terminal 6, terminal 7. So terminals 6 and 7 are running these. This is your positive wire. Your positive wire is leaving there and going down heating element 1 on and off and heating element 2 on and off. I have 2 banks of heating elements. There's 2 elements on each switch. Then they pass through that switch and come up here and go into the SSR control terminal, which is terminal 3. Now it's the positive terminal 3, and then terminal 4, is your negative, and terminal 4 comes back up here to terminal 7 on the PID. Now when the PID turns on, it'll send a signal down to your heating element switch. And this is your manual switch. You don't have to have this. You can just run your solid state relays right off the PID. I chose to have a manual switch so I can have some control. So now when your PID engages to turn on your SSRs, they come down here to these 2 manual heating element switches, because both of these switches are running off the same terminal up here. So whenever this turns on, you're now ready to turn on both sets of heating elements. You turn the switch on, the power leaves, comes out of here, heads over to your positive terminal on the SSR, and then it exits on the negative terminal back to your PID. Now you have engaged that SSR, it's closed the circuit, so these power lines you have running at the top, this power now passes through your solid state relay. And that's the power that goes directly to your heating elements up here. Be careful on touching those are actually hot. Your heating elements have 2 legs of power. One leg of power, in my particular setup, is always hot. It's always got 120 going to one leg. The other leg is coming through the solid state relays. Now that one leg by itself does nothing. It's dead until the second leg is hooked up. The solid state relays engage that second leg. And now you've got 120 on this leg, 120 on that leg. Now you have 240 volts going into your heating elements, and the circuit is complete. Now they'll start to heat up. Now the solid state relays, at least the ones I've got, and I believe all of them, they generate a lot of heat. So you need, because they can switch on and off many times per second. They don't typically. In this setup, they don't. They will turn on and off to regulate the temperature, but the temperature is so high on this that they generally stay on for a long time, and they'll just keep staying on. It depends on what your thermocoupler tells it. The next thing we have in our list of items here, on the heating elements, this side right here is a hot wire coming in. So what happens when you turn this switch on to engage your heating element, you also want to turn on the indicator lamp so that you know your heating element is turned on if you've equipped your panel with an indicator lamp. So you have a 120 hot line here coming from the 120 bank of DIN terminals. That 120 hot line comes in. When you flip the switch, the power goes out to the indicator lamp. And of course, we're all daisy chained on the common side here. So it goes and completes the circuit, your indicator lamp turns on. It's exactly the same thing with the heating lamp switch number 2. These two are exactly the same. The way they're wired, where they're wired, it's all the same. The only difference is heating switch number 1 goes to solid state relay number 1, the positive terminal there, and number 2 goes to solid state relay number 2, the positive terminal 3. The next thing in here is the fan. This is the convection fan that moves air around inside of your oven to keep you from getting hot spots cooling up or cold spots. I only turn this on when I reach the temperature I want, but typically I don't use this too much. It's a big oven, takes a little while to heat up. But the way this is wired, I have my 120 coming in from the 120 bank of DIN terminals. Comes in the bottom of the switch. It leaves this switch, goes into the LED indicator lamp, and I can wire it this way on this indicator lamp because this is a 120 lamp. I can't do it over here on these two the same way because the supply, the signal, the control signal for the solid state relay, this red wire, it's in DC, and it's low voltage DC. It's 6 volts, and it's extremely low amperage. It's not enough to engage these lights. Now, when they do turn on, but they're super, super dim. They're hard to see. But in this case, we're running 120 through here, so we can just run it right through the light. Now we've also run, and you'll see this is high temp wire here. This high temp wire goes all the way into the oven to the convection fan. And then the other wire from the convection fan goes to the neutral terminal block to complete the circuit. Lights, very similar. The only difference with the lights, I didn't put an indicator light in, because if your lights are turned on, you're going to see the lights are on. You don't need an indicator for light. They're their own indicator light. You're taking a 120 line off of here. It comes down, feeds into the bottom. You flip the switch, power goes through, back out to the lights in your oven. Neutral comes back. Neutral goes into the neutral block. Now we have all of our switches done and all of our indicator lights. On your timer, and I believe it was set this way default on mine, that's probably the default setting on all of them. You have the B alarm circuit, which is these two terminals here in the center. These are unpowered terminals. You have to bring power to them. So what I've done is I ran a 120 line from the 120 supply in the DIN rail, and then outputted that to the alarm, and then ran the neutral from the alarm to the neutral DIN rail block. So what happens is when your timer hits whatever time you have it set for, I have mine set for 10 minutes like most powder coaters, and when it hits 10 minutes, this is a normally open circuit, meaning there's no connection between these two normally. When you hit 10 minutes, it closes that circuit. So whatever power you're bringing in here, it will pass through. It might pass out too, but it'll definitely pass through. It brings us to the thermocouple, which is terminals 9 and 10. This is mission critical. If you want your PID to do anything for you, you have to have your thermocouple set up. If you're going to run one, make sure your wires are long enough. Order it longer if you're not sure. Just get it as long as you can. You can always cut it down. You can't stretch them though. So that's an important lesson that I learned the hard way, and something to keep in mind. These can't be used with copper wire, and they're very susceptible to electromagnetic interference. For the voltage meter, because I'm running a 240 system here, what I needed to do was run one from each leg of my 120 power. So this is my line 2, the red one. The black one is my line 1. So you can see in here, here's my line 2 going to the voltmeter, and right in here between the two fat guys is my line 1 going to the voltmeter. This right here is how the voltmeter detects your amperage output. And of course, using 6-gauge wire, you're only going to fit one in here, but you only need one because the amperage travels through both wires. So before you plug it in, you got to obviously feed it through the donut hole, and that plugs in. right here. This little guy right there. That's your ammeter plug. I do have a ground here, as you can see. I am ground lugged to the box, and that goes straight to this steel bracket that I welded together to mount my box to, and that goes straight to this oven. Everything is very grounded. This is actually a ground from my electrical service, but like I said, my panel, the common and the ground are bonded together, which means they're connected electrically. So if you looked inside my service panel, you would see you have your 2 rows of breakers, and then outside those rows of breakers you have that metal bar with all the screw heads on each side of your breakers. You know, the metal bar with all the screw heads and all the wires that are screwed in there. That is your common bus bar, and my common bus bar is bonded or connected electrically to the big ground bar up top where your panel's main ground is, where it goes to the grounding rod that's usually somewhere outside your house. Again, not an electrician. I don't even play one on TV. If you're gonna build your own panel, first of all, good luck. I wish you all the luck in the world. It's not, I would say luck is not needed, but I have somewhat of a grasp on what I'm doing, and I ran into a mountain of problems. You know, they're not monumental, earth-shattering issues, but they're issues nonetheless. And they're things you're going to have to take time to troubleshoot. They're things you're going to have to try different things on. These indicator lamps for bank 1 and bank 2 were an absolute nightmare for me. I tried 3 or 4 different solutions, all of which I was convinced this is going to do it. Before finally I said, you know what, I just need a double pole, single throw switch that's going to run 2 separate circuits, one for the indicator lamp and one for the heating elements. And it was a simple fix, really. It wasn't even an expensive fix. I think these 2 switches together cost me $10, but it's a headache. It's a nuisance, and those kinds of things will make you gray early, but you'll get through them. Like I said, questions, comments, whatever, hit me up in the comments. I will respond as soon as I can. To those of you building your own panels, good luck. I really hope this helps you out. I spent a lot of time scouring the internet for how to wire these panels. I got very poor results. There are videos out there that are titled wiring, control box, powder coat oven, whatever, but very few of them actually went through here and pointed this stuff out. And I remember thinking, crap, man, it sure would be nice if I had a video to look at where I could walk through all this stuff. It's not super complicated. It looks super complicated, but that's because you're looking at 30 or 40 different little circuits, you know, and they're all just spaghetti bowled right on top of each other. That's why it looks so complicated. It's truly not that complicated. I mean, half of what you're seeing right here is that. That's not that complicated. It's pretty straightforward stuff. I thought about doing schematics. That's the whole reason I brought the panel out. I was going to do schematics, and I realized that I'm going to have to do like 10 different full page things here to make it legible and easy to understand. So honestly, when you start spreading things apart like that, you have a tendency to forget something, leave something out, and I don't want to steer you guys wrong. So I just walk you through the panel and show you how it is all actually done. And this works. This panel works. The 17 amps, pretty normal for one leg. 34, that's pretty normal for both legs. You can hear the fan. You can see the light. I'm not going to make you wait around for the alarm. You've seen that already. Thanks for coming to Galt's Garage. I hope you guys got something out of this video. I got something out of doing the video. Besides a powder coating oven, I did learn a little bit. It's a constant learning experience, and that's half the fun in life, learning stuff. So thank you for joining me. This is going to do it for the powder coat oven build. This is the last thing I'll put together for the powder coat oven build. You'll see me using the powder coat oven an awful lot though, because I have plenty of projects that require it, and I've been getting good use out of it, even though I've had to do it manually because of the thermocouple issue. But it's a good oven, it's working great, and I'm excited to get some videos together so you guys can see the kind of things that we're doing here at Galt's Garage. And I will see you on the next video. Be safe.